Hey guys, welcome back to my YouTube channel. In this video, we are going to see delete the middle node of a linked list. This is again a lead code problem. The problem node is 2095. You can find it on the lead code. You just have to enter the number on the search bar and it will redirect you to the problem. So what this problem is saying that you have given the head of a linked list and you have to delete the middle node or middle value of the linked list. In example 1, our middle is 7, so you have to delete the 7, this thing. Okay. In the example 2, just give me a second. In the example 2, you have to delete the mid node. The middle node is 3, so you have to delete the 3 from the linked list. Okay. And same for the example 3. There are two nodes and the middle node is 1. So you have to delete the middle node. So our final linked list will be looking like with one node containing 2. In example 2, if we delete the 3, the middle node, so our final linked list will be look like something 1, 2, and 4. 1, 2, and 4. And in the example 1, if you delete 7, then our final linked list will look like 1, 3, 4, 1, 3, 4, and then 1 to 6. So how can we delete the middle value? Mm, you are getting something, if I am correct. You have to find the middle node, okay? So can you put a slow and fast approach? Yeah, exactly, you can. The slow and fast approach will lead you to the mid. I mean, the slow will be pointing to the mid value. But if you're on the middle value, how can you delete this? Suppose if your slow is on the 7, how can you delete it? If somehow I can reach to the previous node of the middle, then I can see your next. Can you point it to the your slow next? It can. So if I'm standing on a middle value, then I can't delete it. If I'm standing on a 3, then I can't delete this value because I'm standing on top of the middle value, middle node. So I have to somehow reach out the previous node before the middle to delete it. Let's understand it with dry run. Suppose you have a linked list. Suppose you have this linked list, okay, and this is a middle node that you have to delete. Okay, so again, what you can do, you can put fast and slow algorithm means Floyd, Turtledge, and Hare algorithm to find the middle. Okay, so after end of the loop, the slow will be pointing to the middle value, but somehow you have to delete the slow pointer in this case. So, but if your slow is standing on the top of the middle value, then you can't delete it. Somehow you have to reach here and you have to say your next should be pointing to this value. Then it can automatically get deleted. Means if a 4 is pointing to 3 rather than 4, then the 4, the fourth or whatever, the node with the 4 got deleted automatically. So how can we do it? Can I took another pointer def? Initially it will be pointing to the null value. And what I am saying, I am assigning pref. Can you go to the slow? And then I am saying slow, move ahead. Then slow will move ahead. And I am saying fast, can you move 2 step ahead? It will say, yeah, I can. And it's moving 2 step ahead. Slow is moving 1 step ahead. And at the same time, I am saying brave, move to the slow. So brave moves to the slow. Slow moves 1 step ahead. Fast moves 2 step ahead. So it's look like something this. Then again I will say brave, can you move to the slow? Brave moves to the slow. Then again slow moves one step ahead, fast will move two step ahead, fast reaches to the 4. Again, my prev can you move to your slow? Prev moves to the slow. Slow will move one step ahead, fast will move two step ahead. So my fast reaches here. Again, my prev moves to the slow. Slow moves one step ahead. Slow reaches to the middle value, and at the same time fast moves two step ahead and reaches the null. When my fast reaches the null, you can stop here and you can see my prev is pointing just before the slow. Yeah, got it. So you can, from this moment you can directly see prev, can your next put your next to the slow of next. So my next of prev will be pointing to the slow of next, means slow of next is this value, and prev next is pointing to the this value, means this 4 got deleted. Exactly. So our final linked list will be looking like something this, where the middle value is got deleted. So again, we are using the flow and fast algorithm or approach. And I think after watching this many video on the same topic, I think you got the importance of the slow and fast approach in the linked list especially. And in the future, I will tell you the slow and fast approach on the different data structure like array and couple of more. But before that, let's try to code it up on the LeetCode and see whether it's working or not. So let's try to run it on a C++, then I will move to the Java solution. So what do we need? Not, I have to write here. What we need slow. So let's create slow. Least node slow equals to head. It will be pointing to the head. Least node fast. It will be the pointing to the head. And what we need else is a pref pointer. Okay. So we need to make pref pointer. So let's make it a pref pointer. Pref. It will be a null. Initially it will be null. Okay. And what we need to do? We need to apply our fast and slow algorithm. So what will be our condition? While my fast my fast not equal to null, and my next of fast is not equal to null. Okay, not equal to null. And in the while loop, what we need to do? We are assigning prev to the slow. At every time I'm saying prev, can you move to the slow? Prev, can you move to the slow? Prev, can you move to the slow? And then slow moves ahead, one step ahead, and fast will move two step ahead. Okay, so my slow will move to its next, means one step ahead, and my fast will move two step ahead, means fast will move to next of it, any xt. Okay, after this while loop, our prev will be pointing just before the middle value. Our prev will pointing to just before the middle value, that is slow. And I can directly say after this loop that slow, not slow, prev, your next will become what? Slow, next of slow. And I can directly return the head from here. I'm saying that prev, your next will be not the, wait a second, just your next will not be this one, rather than it will pointing to the this value, means next of slow. Okay, and after that this value got deleted. You can see this value got deleted, and if I run it, it should be working. If we haven't done any error, but it's working. Let's submit it and let's move to the Java solution. This video is gonna be short because it's a super easy problem. It's taking quite a time lately. I have been noticing that in my system, I don't know about other system, but it's taking a lot of time to submit an answer. Okay, so it's saying that ref next equals to slow next something error. Okay, let me check the constraint because it's saying it's a null. Okay, so number of node can be one. Okay, okay, I got it. So you have to check if my head cannot be null because it's saying that there are at least one. Still, let's say if my head equal null, but my head equal null, but they can't be. It can't be because there are at least one node in a linked list, and or sorry, or my next of head they should not be null. If they are null, I mean if they are null, you can simply return the null. Means if there are nothing, you can't return. I mean, if there are one node and you have to delete the middle node, means it's the node itself, and you have to delete the node, means you have to return it the null. And I think it should be working now. Again, it's taking a lot of time, and it sees an error. Let's see, because they will be equal. Not equal. They should be equal. This little error, I'm doing it every time. I don't know why. It's not like I have done previously. I'm doing in front of you. So happens. Let's sum it up. And then after then, let's move to the Java solution. Again, it's taking time. Runtime error, no, it was accepted. Okay, so let's move to the Java solution. In the Java, I will paste the whole thing and I will remove the pointer concept because in the Java we don't have any pointer concept, and it will be a small null. Again for here, and same for this, and we don't have an arrow pointer, so use head.next. Same for here, fast.next, fast.next of next, slow.next. Anything else we need to change? Yeah, it's null. It should be small. I think I should be start writing null ptr in C++. In C++, null, capital null, and null ptr do the same thing. Anything else we need to change? I don't think so. Yeah, there. It should be null. And I think it should be running. So I hope you like this video or you like this approach. So if you like, do like and subscribe my channel. And if you have some comment below in the comment box. With this, I'm wrapping this video, and it's probably gonna done. Okay, this was sum it up. So with this, I'm wrapping up the video.